What's going on, you guys? Mr. Allen here. We got ourselves a fun little problem here involving not necessarily parallel lines, right? It says, is L parallel to M? So here's L, here's M. Notice there's no markings on here saying that the lines are parallel. We're asked to find out if they're parallel and to justify. We're going to justify algebraically, all right? So let's think here. What type of angles are these two? They're corresponding angles, right? And if those two angles are congruent, then we get parallel lines. Vice versa, if the lines were parallel, I'd know these two are congruent. But I'm not told whether or not these lines are parallel, so I can't say that these two are congruent. But I do have a 70-degree angle here. What type of angles are these two right here? Those two are vertical angles, or opposite angles, some people call them, which means that they are congruent. And if these two are congruent, I can set them equal to each other. I'd have 3x minus 5 equals 70. And now I can add 5 to both sides. I'll get 75 here, and then I'm going to divide by 3, giving me x equals 25. Well, what can I do with this? Why does this even matter? Well, if I were to plug in 25, I know here I'm going to get 75 minus 5 is going to be 70 degrees, right? I know that one's going to be 70 degrees. I set it equal to 70, and I solved. So it should be 70 degrees. The one in question here is the one that corresponds to it. It's corresponding angle pair, right? If I plugged in 25, I'd have 4 times 25 minus 20. That's going to be 100 minus 20, which is 80 degrees. So are these two angles congruent? No. So then we would say that L is not parallel to M. Okay, so they are not parallel. You could say, oh, nope, not parallel. You could write that out, not parallel. And you would say, well, this angle and that angle are not the same. The corresponding angles are not congruent. There we go. Another nice little piece of reasoning there. I think it would be wonderful to justify and get your work there. That's beautiful. It's a mathematical painting of awesomeness. All right. See ya.